Today we are going to discuss about the physics chapter motion. So the first question comes is, what is a motion? So to understand the motion, let us suppose that we have an object x at point A at time t. We can say t1. At time t1, this object is at point A. Now as the time moves, it becomes t2. The object x change its position from point A to point B. In that case, object x change its position from point A to point B in respect to change in time. In this term, the object x is said to be in motion. Object x is said to be in motion. Okay. So in general, we see many objects, like we see moving vehicles, birds, cycles. As you can see in the picture, the cyclist, the person, the car, bus, train, everything in this picture you can see is changing its position with respect to time. And in that case, we can say that all of these objects are executing motion. But is it same for tree, for this tree and for this tree also? Are they in motion? No, they are not in motion. Why? Because as the time change, these objects, these tree do not change their position. That means they are not in motion. So they are not in motion. Okay. So to understand the motion, we can say that whenever an object change its position with respect to time, the object is supposed to be in motion. So what is a motion? This is a general definition. A body is said to be in motion when it moves from one place to another place. When a body moves from one place to another place, as I said earlier, when a body from point A moves toward point B, then the object is said to be in motion. Okay, we have examples: car traveling from one city to another city, person walking on road. These are the common examples of motion. What will not be in motion? Not in motion. You can see many objects there which are not in motion, like tree, chair, tables, walls. These are some non-living things which are not in motion. Not in motion. So if they are not in motion, then what we will say? We will say that if they are in not motion, then these objects are at rest. These objects are at rest position because they are not changing their uh, uh, position with respect to time. So this is what we call motion. So there are common examples of motion. You can see The house is stationary, it is not changing its position with respect to time. Same applied for tree. But if we say the car, it is moving. Why it is moving? Initially the car was at point A, now it reaches to point B, so the car is also in motion. Now let's discuss about distance and displacement. So as we discussed that for motion an object needs to change its position from point A to point B. So distance is the path traversed by the object, the total path that is covered by the object to move from point A to point B. It is called distance. Okay, like you go from Delhi to Agra, and suppose it took some kilometers, some x kilometers, then this is what we call, this is the distance traveled. This is the distance traveled by the object. So the total path covered by a body moving from one point to another point. Now let's discuss about displacement. So what is displacement? Suppose if we draw a diagram here, this is the y-axis, this is the x-axis. Now let us suppose that object is at point A where its x-axis x1 we can say is 0. As soon as the time pass, the object will start to change its position from 0 to somewhere else, like this point B. And the distance from the origin here is suppose 3 meter. So the displacement will be the change in position. So how much there is a change in the position, like x2 minus x1, that is 3 minus 0 is 3 meter, 3.0 meter positive. Okay, so there one thing to be remember that the displacement and between displacement and distance is a scalar quantity. Okay, so we will only provide the magnitude, like if we say distance 20 centimeter, then this is in general, only magnitude will be represent but not the direction. But in case of displacement we will write down the magnitude as well as the position, like positive or negative, because displacement defines the change in position, whether it is moving towards positive x-axis or negative x-axis. So it will define the position of the object. Okay, so any quantity in which magnitude and directions are represented are called vector quantity. So displacement is a vector quantity because we represent it with magnitude and direction, while the distance is a scalar quantity where we only represent magnitude but not direction.